Hi, I'm Patrick Reagan. Welcome to TCP/IP, Part 17, Dynamic Addressing in DHCP Services. During this video, we discuss how to set up auto-configuring of IP configuration, including IP addresses. Topics include DHCP scopes, reservations, lease time, DHCP options, DHCP relay and IP helper, and IPv6 SLAAC. As with most of my training videos, there are practice questions at the end of the video. If you like this video, make sure to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel. Dynamic Host Configuration Protocol, or DHCP, is a network management protocol used to automatically assign IP addresses and other network configuration settings to devices or clients on the network, allowing them to communicate effectively. DHCP greatly simplifies IP management, especially in large networks. For clients, you should avoid static IP configuration. Key functions of DHCP include IP address assignment, where it automatically assigns a unique IP address to each client; lease duration, which assigns IPs for a limited time, called a lease, after which they must be renewed or will be reclaimed when the lease expires; and network configuration, that supplies clients with other configuration data such as subnet mask, default gateway, DNS servers, and domain name. The four-step process used by clients to obtain IP configuration from a DHCP server is referred to as DORA. Step 1. Discover. The client sends a broadcast DHCP discover message to find available DHCP servers. The client is literally screaming out, "Are there any DHCP servers out there that can help me auto-configure and give me an IP address?" Step 2. Offer. Each DHCP server replies with a DHCP offer proposing an IP address and configuration. Step 3. Request. The client selects one offer and responds with a DHCP request message asking to use the offered IP. In Step 4. Acknowledgement. The chosen server replies with the DHCP acknowledgement, confirming the lease and completing the configuration. The process ensures automated, conflict-free IP assignment in a network. DHCP server listens on UDP port number 67 and client listens on UDP port number 68. The DHCP process begins with clients broadcasting a request. Remember, broadcasts don't go through routers. The client and servers are on a different broadcast domain or subnet. The request will be seen by an IP helper or DHCP relay agent, which will relay the request to a DHCP server. A DHCP relay agent is a service or agent typically configured on a router or layer 3 switch, but could be configured on a computer that converts the DHCP broadcast to a unicast packet and forwards the unicast packet to the DHCP server on another subnet. The relay agent adds its own relay agent IP address so the DHCP server knows which subnet the client is on. An IP helper is a Cisco iOS configuration command that tells a router which IP address to forward certain UDP broadcasts to. The IP helper can forward multiple UDP services such as Trivial FTP, DNS, and NetBIOS, not just DHCP. When you set up DHCP, you have to define scopes and the scope properties for each subnet. A scope is a defined range of IP addresses that a DHCP server is configured to lease out to clients on a particular subnet. A DHCP scope is how the server knows what IPs to assign, to whom, and with what configuration settings. It's essential for DHCP operation on each subnet. Key components of a DHCP scope include the IP address range, which defines the starting and ending IP addresses the server can assign. For example, 192.168.1 to 100 to 192.168.1.200. The subnet mask defines the size of the network. Lease duration is how long an IP address is leased before it must be renewed. Exclusions, which are optional, are IPs within a range that should not be assigned, which are usually used for printers and servers. DHCP options is optional but common, include additional settings like default gateway, DNS servers, and domain name. Some of the common DHCP scope options are shown on the screen. Usually every setup will have the router or default gateway configured with the DNS servers options. Other options are used to enhance your network or simplify some configurations, including configuring a DNS domain name, NTP or time server, and configuring VoIP services. When you configure a DHCP scope, you specify how long a DHCP lease time will last. Lease durations can vary. Shorter leases equals more DHCP traffic but better IP utilization. It is better for dynamic environments such as Wi-Fi and labs. Longer leases equals less DHCP traffic but slower IP reuse and recovery. It's good for static networks found in offices and servers. 8 days is the default. The best practices include monitoring DHCP utilization. If the pool is nearing exhaustion, shorten lease time. Segment pools to use short leases for guest networks and long leases for internal devices. This table shows a recommended lease time based on various environments based on the type of devices used on a network. Most DHCP servers will keep a list of past assignments so that it can try to assign the same IP address to the client. It will try to renew the IP address lease at the 50% mark of the lease time. A DHCP reservation is a configuration that ensures a specific device always receives the same IP address from the DHCP server based on its MAC address. When the client requests an IP, the server recognizes the MAC and always offers the reserved IP rather than the random one from the pool. The device still uses DHCP, but always gets the same IP, like a hybrid between static and dynamic addressing. You can reserve an IP address based on the MAC address so that you always get the same address and to prevent other systems from using the address. Bootstrap Protocol, or BootP, is a legacy network protocol that allows a diskless client to obtain an IP address and boot configuration from a BootP server and boot over the network. It was defined in RFC 951 in 1985 and served as the foundation for DHCP. Similar to DHCP, it provided IP address, subnet mask, and default gateway, and supplies the boot file name and the TFTP server or IP to load that file. It requires manual configuration of each client's MAC address on the server. BootP is mostly obsolete today, but some network boot environments still use BootP-like behavior during initial boot stages, and DHCP servers often still support BootP clients. Pre-boot execution environment, or PXE booting, is a network-based booting method that allows a computer to load and boot an operating system or boot image from a remote server rather than from the local storage like a hard drive or USB. PXE boot is used in Windows deployment services, SCCM, MDT, thin clients in schools or call centers, mass cloning, and diskless workstations. Key components of PXE boot is the PXE firmware, which is built into the NIC, the BIOS, or UEFI. It starts the PXE process during system boot. The DHCP server provides an IP address to the PXE client and may deliver the location of the boot server. The Trivial FTP or TFTP server hosts the bootloader and OS image. The PXE client downloads the files from here. The boot file is a network bootloader that downloads the network bootstrap program to boot the computer and launches the OS installer or image. The simplified PXE booting workload include client boots and starts PXE from the NIC firmware. Client sends a DHCP discover with PXE-specific options. DHCP or proxy DHCP server responds with an IP address, the Trivial FTP server IP, and the boot file name, option 67. Client downloads the boot layer via Trivial FTP, and then the bootloader loads the OS installer or image into RAM and begins execution. DHCP supports IP version 6 through a protocol called Dynamic Host Configuration Protocol for IP version 6, defined in RFC 8415. This is the IP version 6 counterpart to DHCP version 4 and is used to assign IP version 6 addresses and configuration settings to the clients. Features and capabilities include IP version 6 address assignment, DNS server configuration, domain search list, prefix delegation, and centralized lease tracking. It does not specify default gateway since IP version 6 clients relies on router advertisements or RA. DHCP version 6 works in coordination with ICMP version 6 router advertisements. The M flag, which is short for manage, uses DHCP version 6 for addresses. The O flag, short for other, uses DHCP for other information such as DNS settings. The DHCP version 6 modes of operation include Stateless DHCP version 6, which provides only config options such as DNS servers while addresses are signed via SLAAC. Stateful DHCP version 6 assigns IP version 6 addresses in configuration like DHCP version 4. The prefix delegation used by routers to request the subnet prefix from an ISP or upstream router. Stateless Address Autoconfiguration, or SLAAC, is an IP version 6 mechanism that allows the device to automatically configure its own IP version 6 address and default gateway without needing a DHCP version 6 server. Devices generate their own IP addresses using a prefix advertised by the router via Neighbor Discovery Protocol, or ND, specifically through router advertisement or RA messages. Changing the IP version 6 prefix on the router will trigger devices to reconfigure themselves with the new prefix automatically. Advantages of SLAAC include no DHCP version 6 server required, simple and fast setup, and is well suited for modern networks and IoT. Limitations include no centralized address tracking, unlike DHCP version 6, and DNS information not always included unless the RA supports RDNSS. Device generates a link local address upon joining network, and the host creates a link local address and tests for uniqueness using duplicate address detection, or DAD. The router sends a router advertisement, or RA, where routers on the local network periodically or in response to solicitations send ICMP version 6 router advertisement messages. These RAs contain prefix lifetime, and flags indicating how the client should configure its address. Host constructs its global IP version 6 address, where the host combines the advertised prefix with its interface identifier, typically derived from its MAC address or using RFC 7217 privacy methods. No state is maintained on a central server, hence stateless. Optionally, DNS configuration. SLAAC alone does not provide DNS information unless recursive DNS server options, or RDNSS, is included in the RA. Otherwise, DHCP version 6 may be used in parallel for DNS configuration. Automatic Private IP Addressing, or APIPA, is a non-routable link local address that is assigned when a client cannot find or connect to a DHCP server. It will assign itself an IP address. IPAPA addresses begin with 169.254 and has a subnet mask of 255.255.0.0. Therefore, if you see a client that has an address that begins with 169.254, for whatever reason, the client could not get a DHCP address from a DHCP server. If you see an IPAPA address, you should check if the computer is connected to the network, including cables or wireless connections, the DHCP server is running that handles the automatic IP configuration of a system, the DHCP helper or relay agent can forward the DHCP request to the DHCP server, and the DHCP scope has not run out of IP addresses. Address pool exhaustion in DHCP occurs when the DHCP server has no more IP addresses available in its configured pool to lease to new clients. This means the devices requesting an IP address will not receive one, resulting in network connectivity failure. This is caused by too small of a scope or pool, which is the defined IP range or scope doesn't have enough addresses to accommodate all devices. IP address hoarding, where devices hold on to leases longer than necessary, especially with long lease durations. Stale leases, where IPs are still marked as in use even though the clients are no longer active, such as when devices removed from the network but not released. Unauthorized rogue devices, where devices not meant to be on the network consume IP addresses. Shortage due to subnetting, where misconfigured or overly segmented subnets reduce the number of usable addresses. Improper reservations, where too many IPs are reserved for specific devices, reducing the available dynamic pool. And DHCP denial of service or DOS attacks, where malicious clients repeatedly request IPs until the pool is exhausted. How to prevent or mitigate address pool exhaustion is increase the size of the DHCP pool, decrease lease duration to recycle unused IPs faster, regularly clean up stale leases, enable IP conflict detection or use DHCP snooping, implement network access control to block unauthorized devices, and monitor DHCP logs and alerts for early signs of exhaustion. IP address management, or IPAM, is a system or set of tools used to plan, track, and manage IP address allocation in a network. It integrates with DHCP and DNS to provide centralized visibility and control over IP address usage. You can use IP address management, or IPAM, to help monitor or report on IP address shortages. A rogue DHCP server is an unauthorized DHCP server on a network that corresponds to client DHCP requests, potentially providing incorrect IP addresses, gateway information, or DNS settings. This can cause serious network problems and security risks, including network disruption, where clients may receive wrong IP addresses, causing them to be on the wrong subnet or unable to communicate. Man-in-the-middle attacks, where attackers can provide a malicious default gateway or DNS server to intercept traffic. IP conflicts, where the rogue DHCP server may issue addresses that overlap with valid assignments. And security breaches, where malicious servers may be used for phishing, malware delivery, or traffic interception. To prevent rogue DHCP servers, use tools like Enable DHCP Snooping, which is available on Cisco, HP, Juniper, and other managed switches that allows DHCP replies only from trusted ports where real DHCP servers reside. Wireshark, which you can filter by bootp or udp.port == 67 DHCP Sentry. DHCP Probe, rogue DHCP detectors by third-party tools. Nmap, using script broadcast DHCP discover commands. And switch port monitoring, which uses port mirroring to analyze DHCP offers on specific VLANs. Microsoft DHCP servers include a security and control mechanism where you have to authorize the DHCP server for an Active Directory domain before it can hand out IP addresses on the network. This is the reason that in the screenshot, the IPv4 and IPv6 servers are down because the server has not been authorized in Active Directory to assign IP addresses. Question: which of the following attacks would most likely cause duplicate IP addresses in a network? Answer: rogue DHCP server. Question: a virtual machine has the following configuration: IPv4 address of 169.254.10.10 and a subnet mask of 255.255.0.0. The virtual machine can reach co-located systems but cannot reach external addresses on the internet. Which of the following is most likely the root cause? Answer: the DHCP server is offline. Question: an IP address is maintained despite a failing UPS that causes a workstation to restart several times. Which of the following would allow this to occur? Answer: DHCP reservation. Question: you know the MAC address of a device and is attempting to find the device's IP address. Which of the following should the technician look at to find the IP address? Choose two answers. Answers: ARP table and DHCP leases. Question: you create a new network 10.10.0.0/24 on a DHCP server. You want to ensure that 10.10.0.10 through 10.10.0 through 15 are not allocated to other devices. Which of the following features should the administrator configure? Answer: exclusion. Question: which of the following describes the best device to configure as a DHCP relay? Answer: router. Question: you're managing a DHCP scope but needs to allocate a portion of the scope subnet for statically assigned devices. Which of the following DHCP concepts would be best to use to prevent IP conflicts? Answer: exclusion range. Question: which of the following would need to be configured to ensure a device with a specific MAC address is always assigned the same IP address from DHCP? Answer: reservation. Question: you're using a DHCP server with 12-hour leases for its device configurations. The user records the information that the DHCP server provides and uses the information to connect to a device with a manual IP set. Over time, the user experiences intermittent connectivity and recurring connection timeouts. Which of the following is the most likely cause of the problem? Answer: a duplicate IP address is on the network. Question: a network engineer needs to change an entire subnet of SLAAC configured workstation addresses. Which of the following methods would be the best for the engineer to use? Answer: Change the address prefix in the router in order for the router to advertise the new prefix with an ND. Question: which of the following services provides the network information for the address when IPv6 is used for SLAAC addressing? Answer: router advertisement. Question: a network administrator decided to use SLAAC in an extensive IPv6 deployment to alleviate IP address management. The devices were properly connected into the LAN, but auto-configuration of the IP address did not occur as expected. Which of the following should the network administrator verify? Answer: the network gateway is configured to send router advertisements. Question: you're setting up a new phone system. It needs to define the location where VoIP phones can download configuration files. Which of the following DHCP servers can be used to accomplish this task? Answer: scope options. For more information, visit these sites. In summary, Dynamic Host Configuration Protocol, or DHCP, is a network management protocol used to automatically assign IP addresses and other network configuration settings to devices or clients on the network, allowing them to communicate effectively. DHCP greatly simplifies IP management, especially in large networks. For clients, you should avoid static IP configuration. The four-step process used by clients to obtain IP configuration from a DHCP server is referred to as DORA. If the client and server are in different broadcast domains or subnets, the request will be seen by an IP helper or DHCP relay agent, which will relay the request to a DHCP server. A DHCP scope is a defined range of IP addresses that a DHCP server is configured to lease out to clients on a particular subnet. A DHCP's reservation is a configuration that ensures that a specific device always receives the same IP address from a DHCP server based on its MAC address. Stateless address autoconfiguration, or SLAAC, is an IPv6 mechanism that allows the device to automatically configure its own IPv6 address and default gateway without needing a DHCP version 6 server. In SLAAC, devices generate their own IP addresses using a prefix advertised by the router via Neighbor Discovering Protocol, or ND, specifically through router advertisements or RA messages. Automatic Private IP Addressing, or APIPA, is a non-routable link local address that is assigned when a client cannot find or connect to a DHCP server and will assign itself an IP address. IPAPA addresses begin with 169.254 and it has a subnet mask of 255.255.0.0. A rogue DHCP server is an unauthorized DHCP server on the network that responds to client DHCP requests, potentially providing incorrect IP addresses, gateway information, or DNS settings. Thank you for watching this video. The next video will be TCP/IP Part 18, IP Troubleshooting Part 1. If you like this video, make sure to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.